Okay. Yes. Good evening, Mansi, Abhijit, Anika, Abhay. Good evening, all. Ralam.
Get up to 70% off on 2000 plus gadgets.
Yes. So let us start. Karma present. Okay. Yes. So we have done up to question number 26. Okay. Now question number 27 of chemical bonding. Okay. So 27th question is draw diagrams showing the formation of a double and triple bond between the carbon atoms in the C2H2 and C2H4. Okay, this is the question. So we have already done this question in the conceptual part in theory in the even hybridization. Then when we explain hybridization of ethine and ethene, tell me in ethine what is the hybridization of carbon? Oh, only I am visible to you. Oh my god. Sorry, beta. Sorry. 1 second. Wait for some time. Sorry, beta. Yes, now. Yes, now is it okay? Yes, beta. Is it okay now? Okay, thank you so much for your patience. Actually, I'm new to the system, so okay. Let's start now. See, question is draw diagrams showing the formation of a double and a triple bond between carbon atoms in C2H2 and C2H4 molecules. Now tell me, what in hybridization we have done this. What is the hybridization of carbon in C2H2 and in C2H4? What is the hybridization of carbon? What is the hybridization of carbon? Very good. Who is this crazy works? So, carbon is sp hybridized. So, one sp hybridized overlap with one s of hydrogen and other overlap with sp hybridized orbital of carbon. Same is the other one. And then remaining two unhybridized p orbital. I'm explaining it in short because we have already done it. So they will overlap like this. And that's why there are four electron clouds, one above the plane, other below the plane, and right, left, and upper and lower, means above the plane, below the plane. Okay, Amritya, Amritya, okay. So cylindrical pi electron cloud is formed, that we have done, if you remember. And second one is, so there is a formation of triple bond, okay, when two p orbital, unhybridized p orbitals on each carbon overlap with the other carbon. And in ethyne, each carbon is sp2 hybridized. Very good. Okay, wait. Hello. Yes. Yes. Okay. Now is it okay? Now tell me. Now. Is it okay now? Oh, okay. So let me. Okay. So see, it is like this. So there are unhybridized p orbital on each carbon that overlap sideways. So there is one electron cloud above the plane and other cloud below the plane. So that is the diagram showing the formation of double bond. So in ethene, each carbon is sp. You can explain hybridization this question. Okay, done. So now next question. Next question is, what is the total number of, question number 28. What is the total number of sigma and pi bonds in the following molecules? Okay, so first is C2H2 and second one is C2H4. Same. Yes, tell me now. How many sigma and pi bonds are present? You know, C2H2 can be represented as C triple bond CH H. So, very good. See, this is sigma bond. One of them is sigma bond because between two atoms there is only one sigma bond. Between two atoms there is only one sigma bond. Rest are pi bonds. So that means these two are pi bonds and one in the middle is sigma. So there are three sigma bonds and two pi bonds. Now C2H4. In C2H4 you have drawn the structure just now. It is like this. Very good, Namita. Sigma, 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 sigma. One bond is always sigma bond. Single bond is always sigma bond. And multiple bonds are pi bonds. Okay. Multiple bond means 1 plus 1. Then one is sigma, one is pi. If there are three, sigma is only 1 and rest are pi bonds. Very good. So total 5 sigma bonds and 1 pi bond. You can write separately that there are 2 CH sigma bonds and 1 CC sigma bond and 2 CC pi bonds. In this case, 4 CH sigma bonds, 1 CC sigma bond and 1 CC pi bond. Right? Okay, this is question number 28. Now 29. 29 is considering x-axis as the internuclear axis, which out of the following orbitals will form sigma bond. अच्छा, again voice problem यार. Hello. 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 Yes, बेटा. सिद्धार्थ. अब. Hello. Yes, बेटा. सिद्धार्थ. Hello. सिद्धार्थ. Hey, Vibhu. Hey, close करो. Door close. Okay. बेटा अभी कैसी आ रही है आवाज? यार वॉइस क्लैरिटी क्या प्रॉब्लम है? अब कैसा है? Now is it okay? Yes. बोलो बेटा. Okay. Yes. Now see, we have question considering x-axis as the internuclear axis. Which out of the following orbitals will form a sigma bond? So no, and it is 1s 1s and 1s 2px and 1s 2py 2py. One s and 2s. So tell me, between 1s and 1s, which type of bond is formed? One s and 1s, Tell me. Between 1s and 1s, which type of bond is formed? Sigma or pi? Yes. Between 1s and 1s, which bond is formed? Sigma or pi? Fast. Respond fast. It is very easy question. बोलो बेटा. नहीं. The 1s is, you know, non-directional. So 1s or 1s में there is always formation of sigma bond. And 1s when it is along with 2px, 2px जो है, that is x axis is internuclear axis. That means this dumbbell is along x axis. So obviously there is a formation of sigma bond. Two py and 2py. Very good, Siddharth. Very good. It is pi bond because it is not along the internuclear axis. So there is a formation of pi bond. Okay. And 1s and 2s, again there is a sigma bond. Okay. So this is question number 29 and then question number 30. Okay, better to write here only. Question number 30. So it is, which hybrid orbitals are used by the carbon atoms? In the following? Okay, it's okay. Okay, Siddharth, thank you for the information. In the following molecules, CH3, CH3, second is CH3, CH, double bond CH2, CH3, CHO, D is CH3, COH. Okay, so these are the molecules. Okay, so tell me, in the first case, you can write it like this. So to find out the hybridization of the molecules involving carbon, there is a finger rule. See, these are the 4 fingers. So when you have 4 sigma bonds, sigma bond. Okay, so if there are 4 sigma bonds, hybridization is sp3. If there is 1 pi and 3 sigma, then it is sp2. If there are only 2 sigma bonds, hybridization is sp. That's it. 4 sigma bonds, sp3. Okay, 4 sigma bonds, sp3. 3 sigma bonds and 2 sigma bonds. That's the theory. For all the 4 sigma bonds, sp3. 4 sigma bond plus 1 pi, sp2. 2 sigma bond plus 2 pi, sp. That's the rule. So in this case, see, all the 4 sigma bonds, all the 4 sigma bonds. So each carbon is sp3 hybridized. Okay, in this case, draw the structure. This is A, now in B. Like this. So this carbon has all the 4 sigma bonds, 1, 2, because single bonds are always sigma bonds. So hybridization is sp3. This carbon 1, 2, 3 sigma bonds, 1 pi bond. So sp2. This one again. So sp2. Right? Yes, beta. Very good, Sakshi, Namita, Anika, Siddharth. Good. Very good, very good. That's great. Now, in case of C, you know, CH3, CH, C, it is double bond O and H, because CHO group means C double bond O, H. So this carbon has all the 4 sigma bonds. So sp3, and this carbon 1, 2, 3 sigma bonds and 1 pi bond. So sp2. Next CH3, double bond O, OH. Okay, so in this case, this carbon is attached to sigma bonds only, sp3. And what about this? Sigma, 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 pi. 3 sigma bonds and 1 pi bond, again sp2. That's it. I think you, very good, Abhay. I think you have no doubt in hybridization. Any doubt up to this? Next question. Let's do. This is question number 30 actually. Okay, right. So let's go to next question. 31. Question number 31. What do you understand by bond pair and lone pairs of electron? What do you understand by bond pairs and lone pairs of electrons? Thank you, Karma. What do you understand by bond pairs and lone pairs of electrons? Illustrate by giving one example of each type. Yes, tell me, what do you mean by bond pairs? When there is a formation of a bond, there is a shared pair of electron between two atoms, that is called bond pair. And if there is a pair of electron on the atom which is unshared, that is called very good Namita, very good Karma. It is from NCERT beta. Karma, it is NCERT of class 11. So you know, you can take example of methane. In methane, carbon has 4 electrons, 4 valence electrons. Each electron is shared with hydrogen. 1 electron shared with hydrogen. So there are formation of 4 bond pairs. So CH4 has 4 bond pairs, right? But if we talk about ammonia, in ammonia has ammonia has 4 electrons. Sorry, nitrogen has 5 valence electrons. Out of 5, 3 are electron. 3 electrons are shared with hydrogens. Okay, so now in ammonia, nitrogen has 1 lone pair because one pair is unshared. This is unshared pair of electron, that is called lone pair. And rest are bond pairs. So it has 1 lone pair and 3 bond pairs. That's it. ठीक है बेटा? Very simple question. Okay. Next is distinguish. 32 question. Question number 32. Distinguish between sigma and pi bond. We have done it earlier. Distinguish between sigma and pi bond. We have done few points. Okay, next is explain the formation of H2 molecule on the basis of valence bond theory. On the basis of valence bond theory, that also we have done formation of H2. In the theory part we have done it. Okay, you can go through that theory. Okay, question number 34. Write the important conditions. Yes, that you should write now. Write the important conditions required for the linear combination of atomic orbitals to form molecular orbital. Yeah, what are the important conditions required for the linear combination of atomic orbitals to form molecular orbitals? Yes, tell me. To form molecular orbital, either crust is over crust or crust is over trough. Is a formation of bonding molecular orbital and anti-bonding molecular orbital. And what are the conditions required? That energy of the atomic orbitals is almost same. They have same symmetry. See, first condition is energy of combining atomic orbitals is almost similar or almost same. There is a slight difference in energies. And second condition is they should have proper symmetry. They should have proper symmetry. Like 1s overlap with 1s, 2px overlap with 2px, 2py overlap with 2py, 2pz overlap with 2pz, but 2px cannot overlap with 2py or 2px cannot overlap with 2pz. That means they should have proper symmetry. And third condition is overlapping, the extent of overlapping should be large. You can add extent should be large. These are the three conditions, and then there is addition of wave function and subtraction of wave function. But these are the essential conditions, that energy almost same, symmetry same, overlapping maximum. So this is the 33 question number. Now '33, sorry, 34. Now 35. Question number 35. That is, use MOT, means use molecular orbital theory to explain why Be2 molecule does not exist. Yes, tell me why beryllium 2 does not exist. On the basis of MOT. On the basis of MOT, molecular orbital theory. So according to this, molecular orbital electronic configuration of Be2 is sigma 1s2, sigma star 1s2. Beta, wait. Yes, Namita is right. That bond order, we should explain it on the basis of bond order in case of. Abhay, you have written it is on the basis of VBT, valence bond theory. Okay. On the basis of MOT, we will write the electronic configuration and then we calculate bond order. Bond order is number of bonding electrons minus anti-bonding divided by 2. So bonding electrons 2 plus 2, 4 minus 4 over 2. So it comes out to be 0. Siddharth, this is the explanation. That on the basis of MOT, if you would like to explain why helium-2 does not exist, why beryllium-2 does not exist, why neon-2 does not exist, you should write that their bond order is 0, because bonding electrons is equal to anti-bonding. See, when 1s 1s overlap, we get sigma 1s, sigma star 1s. When 2s 2s overlap, we get sigma 2s and sigma star 2s, because beryllium, its electronic configuration is 1s to 2s2. So Be2 has 8 electrons and they are written like this. Okay, so this is question number 35. Okay, so now question number 36. In 36, compare the relative stability of the following species and indicate their magnetic properties. First is O2, O2 positive, O2 negative, and O2 2 negative. Now keep in mind, O2 is superoxide and O2 2 negative is called peroxide. Okay. Now let us write the electronic configuration of O2. So for O2, configuration is sigma 1s, sigma star 1s, sigma 2s, sigma star 2s, sigma 2pz, pi 2px, and pi 2py are degenerate, then pi star 2px, pi star 2py, and last is sigma star z. Very good, Namita. This is the electronic configuration actually. Okay, we will write this electronic configuration. Now in O2, how many electrons are there? Tell me. Okay, Siddharth. The total electrons are 16 now. So out of 16, 2 in sigma 1s, 2 plus 2, 4, 6, 8, 10, 11, 12, 13, 14, 15, 16. Done. Now 2 plus 2, 4, 6, 8, 10, 12, 14 and 16. So 1, 1 because both have same energy. They are equal in energy, right? So this is in the order of increasing energies. Now as they have one unpaired electron each, O2 is paramagnetic, O2 is paramagnetic because it has unpaired electrons. Okay, and what is the bond order? Bond order, that is equal to bonding minus anti-bonding divided by 2. Bonding 2 plus 2, 4, 6, 8, 10. 10 minus 2, 4, 5, 6. So that is 2. Bond order is 2. So O2 is paramagnetic because it has unpaired electrons and bond order is 2. In O2 positive, in O2 positive, one more electron is added, rest is same. See, up to this, it is same. Only one electron is removed from this is same, but it is pi star 2px, pi star 2py. Again, O2 positive is paramagnetic because of the same reason. Again, it has electron and bond order is equal to now 10 minus 5, because now one electron is removed from bonding. So bond order is increased by half. Right? Now O2 negative. See, up to this, again, everything remains same. One electron is added. So rest part same, pi star 2px, pi star 2py. So O2 negative is again paramagnetic. Now bond order is, now one electron is added in antibonding. In O2 positive, one electron is removed from antibonding. So bond order is increased by half. Very good, Namita. So it is 10 minus 7 now. So 3 by 2 means it becomes 1.5. Now O2 2 negative. This part again up to this remains same and 2 electrons are added. So pi star 2px, pi star 2py. It becomes 2. So now O2 2 negative is, because all the electrons are paired now, so it is diamagnetic. And 10 minus. Now, one thing that you should keep in mind, that stability is proportional to bond order. Stability is proportional to bond order. Okay, so arrange them in the order of increasing bond order or decreasing bond order. Okay, so it is relative stability is O2 positive is greater than O2, O2 negative and O2 2 negative, because it is, see, highest bond order of O2 positive, so O2 positive is more stable than O2, then O2 negative, and O2 2 negative is 1 only. So this is the order. That is very important question. So this is question number 36. Now